Okay, so I'm going to be going over some question 9s and question 8s, so basically like the last question in section A of paper 1 on some various HL math papers. So the first question, as you can see on the screen, states that we have some line, subscript theta, which has the equation r equals 5, 0, 0 plus lambda 5 sine theta cosine theta for some theta, we don't know. And then the plane, subscript p, just simply has the equation x equals p, right? And then what we're going to do here is we're going to consider the normal of this plane, right? And quite simply, as this is the equation of the plane in the Cartesian form, we can see that the plane of the normal is simply this. Because generally, if we have some plane ax plus by plus cz equals d, then the equation of the normal is just a, b, c, like this, right? So that's the equation of that normal. And we have the direction of this line, so therefore, we can find, by using the dot product, the angle between the line and the normal. And then we can do pi over 2 minus that angle to get the angle between those things. And then hopefully when we do that, we'll see that that angle we get does not include any theta or p terms. So 1, 0, 0 dotted with 5 sine theta cos theta, which will equal the magnitude of, well, instead of writing it out, let's just say the magnitude of this one multiplied by the magnitude of this one multiplied by the cosine of the angle between the normal and L theta, right? So if we write this out, we have 5 plus 0 plus 0. So 5 equals the magnitude of the first one, which is just 1 squared, multiplied by the magnitude of 5 squared plus sine squared theta plus cos squared theta, multiplied by cosine, and let's just give this symbol, this being the angle between the line L theta and the normal to the plane P, plane subscript P. So we can work this out, and what we'll see is that we have sine squared theta plus cos squared theta, and hopefully you know that's just 1. So we have 5 equals the square root of 1 squared is just 1, and then 25 plus 1, so 26 multiplied by cos of that angle. So then we'll find that cos of that angle is simply equal to 5 over root 26, and therefore that angle is simply equal to the arc cos of 5 over root 26. And then we know that the angle that we want, the angle in between them, is simply equal to pi on 2 minus this angle in between the normal and the line. So that's simply equal to pi on 2 minus arc cos of 5 over root 26. And as we can see, there are no theta terms and there are no p terms, and thus it's independent of theta and p, and that's your solution. Okay, this one's slightly trickier. So we have this equation, and we know that 2 of the roots are log 2, 6, and I root 3. Now immediately off the bat, we know that minus I root 3 is also another root because it's the complex conjugate of this one. But we don't know the fourth one. But we can figure this out using the fact that we know that the sum of all 4 roots is 3 plus log base 2, 3, right? So let's just call this fourth root r, and then we can work it out, right? Because that means log 2, 6 plus I root 3 minus I root 3 plus r is equal to 3 plus log 2, 3, right? So these cancel out, and then we get that r is equal to 3 plus log 2, 3 minus log 2, 6. And by the log rules, we can say that's 3 plus log base 2 of 3 over 6, which is just 1/2. And we can also see that 2 to the power of what is 1/2? Well, that's -1, so this is all just equal to -1. And therefore, r equals 2. Right, so now we have all 4 of our roots. And then what we want to do next is we want to somehow find some sort of way we can get a and d into one equation, right? Because we're supposed to show that 6a plus d plus 12 equals 0. Well, we know by the basic product and sum rules of roots that minus a over 1 is equal to the sum, so 3 plus log 2, 3. And therefore a is equal to -3 minus log 2, 3. But then we also know by the product of roots that d over 1, so just d, is equal to the sum of all these things. So that's log 2, 6, multiplied by r, which is just 2, multiplied by I root 3, multiplied by minus I root 3. Right, and if we simplify this down, this is simply equal to 6 times log base 2, 6. Right, I'm sure you can do that bit by yourself. So now we have d, and now we have a, so hopefully we can put some stuff together. We want 6a, so 6a is equal to -18 minus 6 times log base 2 of 3. So then let's add them. 6a plus d is equal to -18 minus 6 log base 2, 3 plus 6 log 2, 6. We can split this up. So this bit by itself will be equal to 6 times log 2 of 3 plus log 2 of 2 because of the log rules. And then we can simplify this further because log 2 of 2 is just 1. So log 2, 3 plus 1. Now if we put that back into there, we can see that we have -6 log 2, 3 plus 6 log 2, 3. So those cancel. And then we also see, because when we expand this out, we have 6 and we have -18, right? So -18 plus 6 simply equals -12. So this whole thing just becomes -12. And therefore 6a plus d plus 12 equals -12 plus 12, which equals 0. And there you go. Okay, next question. So we have z plus 2i all cubed is equal to 216i. So we know 216i is equal to 216 multiplied by cos of pi on 2 plus 2 pi n plus I sine pi on 2 plus 2 pi n. Right, because everything inside this big bracket is just I. And therefore z plus 2i all cubed is equal to that, right? So if we take the cube root of that, we know that 216, the cube root of 216 is just 6. So therefore z plus 2i equals 6 multiplied by, and then because we can use the rule where you take the power here and you distribute it into the what you're cosigning and what you're signing, and this is a property you can find in the formula booklet. We know that this is therefore equal to cosine of pi on 2 plus 2 pi n all over 3, because it's equivalent to the power of 1/3, plus I times sine of pi on 2 plus 2 pi n over 3. So this will work. This will find us the cube root of this entire expression there if we input values of n, 0, 1, and 2, because there'll be 3 roots to this. So first, let's go n equals 0. If you substitute n equals 0 into that, we're just going to get cosine of pi on 6 plus I sine pi on 6. And hopefully you know this is simply equal to 6 times root 3 over 2 plus 1/2 I, which gives us 3 root 3 plus 3i. And that's z plus 2i, so z plus 2i equals 3 root 3 plus 3i, and therefore one solution of z is 3 root 3. Subtract 2i from both sides plus I. So that's one solution. Next solution we get from working out n equals 1. So we could just input n equals 1 into here again, and we'll get 6 multiplied by cosine of 5 pi on 6 plus I times the sine of 5 pi on 6. And once again, hopefully you can work that out. That is minus root 3 over 2 plus 1/2 I, which is then equal to minus 3 root 3 plus 3i. Right, and this is once again equal to z plus 2i, and therefore z is equal to minus 3 root 3 plus I. That's our second solution. And then finally, input n equals 2 into the equation, and we get 6 multiplied by cosine of 3 pi on 2 plus I sine of 3 pi on 2, which will give us 6 multiplied by 0 minus I, which gives us minus 6i. Therefore z plus 2i equals minus 6i, z equals to minus 8i, and that's your third solution. And that's it.